Preparing for a software engineering at HCA Healthcare interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a microservices platform for patient scheduling across HCA Healthcare facilities? I would separate scheduling, provider availability, patient identity, facility data, and notifications into independently owned services. The scheduling service would reserve appointments using transactional safeguards, while events publish confirmations and cancellations through a durable broker. APIs would enforce authorization, audit every access, and expose correlation IDs. I would use ID impotency keys, retries with backoff, and clear ownership boundaries. Strong consistency belongs around reservation. Eventual consistency is acceptable for search and notifications. While answering, cover service boundaries, appointment ownership, facility and provider availability, API contracts, consistency, asynchronous events, security, observability, failure handling, and interoperability with existing clinical systems. Question 2. What does HIPAA mean for the design of healthcare microservices? HIPAA changes security from an add-on into a design constraint. I would minimize protected health information, encrypt data in transit and at rest, apply role-based or attribute-based access, and record tamper-resistant audit events. Logs must avoid sensitive payloads, while retention and deletion follow policy. Service identities need short-lived credentials and least privilege. I would also validate vendors, monitor anomalous access, and rehearse breach response procedures with compliance and security teams. Make sure to cover minimum necessary access, encryption, identity controls, audit trails, data retention, business associate responsibilities, secure logging, incident response, and separation of protected health information from operational metadata. Question 3. How would you choose service boundaries for a healthcare application? I begin with business capabilities rather than technical layers. Patient identity, scheduling, billing, clinical documents, and notifications usually have different ownership, workflows, and scaling needs. Each service should own its data and expose stable contracts. I avoid splitting a single transaction across many services unless the business process truly requires it. Domain events coordinate longer workflows. The best boundary minimizes coupling while allowing teams to deploy and evolve independently. In your answer, talk about business capabilities, data ownership, transaction boundaries, change cadence, team ownership, regulatory concerns, coupling, domain events, and avoiding both distributed monoliths and excessively small services. Question 4. How would you secure an API that exposes patient records to authorized applications? I would authenticate callers with OpenID Connect or OAuth 2.0 and authorize every request using scopes, roles, patient relationship, and purpose of use. Tokens should be short-lived, and services should validate issuer, audience, and signature. TLS protects transport, while field-level filtering prevents unnecessary disclosure. I would add rate limits, input validation, immutable access logs, and alerts for unusual behavior. Authorization must remain server-side, never delegated to clients. Be sure to mention OAuth 2.0 or OpenID Connect, scope tokens, service identity, consent, authorization decisions, encryption, auditability, rate limiting, validation, and protection against excessive data exposure. Question 5. How would you integrate an HCA application with EHR systems using healthcare interoperability standards? I would prefer FHIR APIs for modern resource-based exchange and use HL7 version 2 adapters where legacy systems require messages. An integration layer would normalize identifiers, map terminology, validate schemas, and preserve source provenance. Messages need acknowledgements, durable queues, replay support, and ID impotency to prevent duplicate updates. I would isolate partner-specific behavior behind adapters and test realistic edge cases, including mismatched patients, partial data, delayed results, and terminology version changes. Focus on HL7 version 2, FHIR resources, terminology mapping, patient matching, acknowledgements, retries, duplicate prevention, versioning, consent, and handling incomplete or inconsistent clinical data. Question 6. How would you handle consistency when scheduling an appointment across multiple services? I would keep the appointment reservation atomic within the scheduling service using optimistic concurrency or a short database transaction. Downstream actions, such as notifications and billing updates, would follow through an outbox event and Saga workflow. If a later step fails, compensating actions or a pending state make the outcome explicit. Idempotency keys prevent repeated submissions. I would avoid distributed transactions because they increase latency and reduce availability across independently operated services. Cover reservation semantics, optimistic concurrency, idempotency, sagas, compensating actions, conflict handling, transaction boundaries, user visible statuses, and why distributed two-phase commit is usually avoided. Question 7. What is the transactional outbox pattern, and where would you use it in healthcare systems? The outbox pattern solves the risk of updating a database and publishing an event separately. When an appointment changes, the service commits the business record and an outbox row in one local transaction. A publisher later sends that row to the broker and marks it delivered. Retries handle outages, while consumers remain idempotent because delivery may repeat. This provides reliable integration without requiring distributed transactions, though operational cleanup and monitoring are essential. Explain the dual write problem, local database transaction, outbox record, publisher process, retries, deduplication, ordering, cleanup, and examples such as appointment or patient notification events. Question 8. How would you make a patient-facing healthcare API highly available? I would deploy stateless API instances across availability zones behind a load balancer, with autoscaling based on meaningful saturation metrics. Data stores need replication, tested backups, and a documented recovery plan with RTO and RPO targets. Timeouts, circuit breakers, bulkheads, and queues isolate failing dependencies. Read-only features might remain available during partial outages. Health checks should distinguish readiness from liveness, and deployments require rollback automation and controlled migrations. In your answer, cover stateless instances, multi-zone deployment, load balancing, database resilience, graceful degradation, dependency isolation, health checks, backups, disaster recovery objectives, and safe deployments. Question 9. How would you design observability for a distributed healthcare application? I would instrument every request with a correlation ID and propagate it through APIs, queues, and database operations. Metrics should cover latency, error rate, saturation, queue age, and business outcomes such as booking failures. Distributed traces reveal cross-service bottlenecks, while structured logs support searchable diagnosis without exposing PHI. Audit events remain separate and access controlled. Alerts should map to service-level objectives and actionable failure modes, not simply produce noisy threshold warnings. Mention structured logs, metrics, traces, correlation identifiers, privacy-safe fields, service-level objectives, dependency dashboards, alert quality, audit events, and distinguishing technical failures from clinical workflow failures. Question 10. How would you prevent duplicate processing of clinical or scheduling messages? I assume messages can be delivered more than once. Each message receives a stable event identifier, and the consumer records processed identifiers or enforces a business-level unique constraint before applying changes. The handler acknowledges only after the effect is durable. Retries are safe because repeating the same operation produces the same result. I would not promise exactly once delivery. Instead, I design exactly once business effects where practical and monitor poison messages separately. Be sure to discuss idempotency keys, unique constraints, deduplication storage, message identifiers, retry behavior, ordering, consumer acknowledgements, and the distinction between exactly once effects and exactly once delivery. Question 11. How would you version APIs used by multiple healthcare partners? I prefer backward compatible, additive changes first, new optional fields, tolerant readers, and stable meanings for existing fields. Breaking changes need an explicit version, migration guide, contract tests, a support window, and usage telemetry. Content negotiation or versioned paths can make behavior clear. I would communicate deprecation dates to partners and provide parallel operation during migration. In healthcare, compatibility matters because external systems often upgrade slowly and cannot be changed together. Cover backward compatibility, additive changes, semantic versioning, explicit deprecation, consumer communication, contract testing, content negotiation, migration windows, observability, and avoiding unnecessary breaking versions. Question 12. How would you design audit logging for access to patient information? An audit record should identify the actor, service, patient or resource, action, timestamp, source, purpose, and result. I would generate it at the authorization boundary, send it to append-only storage, restrict access, and protect integrity with tamper detection. Diagnostic logs should exclude PHI and remain operationally separate. Synchronized clocks and consistent correlation IDs support investigations. Retention, review, and alerting rules should be defined with compliance rather than invented by developers. Focus on who, what, when, where, purpose, outcome, immutability, access controls, retention, alerting, clock synchronization, and keeping audit records distinct from diagnostic logs. Question 13. How would you handle protected health information in application logs and error messages? I use an allo list of safe fields instead of logging arbitrary request objects. Patient names, diagnoses, identifiers, tokens, and full payloads should be redacted or replaced with controlled references. Error responses expose a generic message and correlation ID, while internal details remain protected. Middleware can scrub headers and traces, but tests must verify it. I also avoid PHI in URLs, enforce retention limits, and treat third-party observability tools as governed data processors. Discuss data minimization, structured logging, redaction, allo lists, exception handling, tokenization, secure tracing, access controls, retention, testing, and avoiding identifiers in URLs or stack traces. Question 14. How would you test a microservice that processes patient appointment updates? I would unit test validation, authorization, state transitions, and ID impotency decisions. Integration tests would verify database transactions, outbox behavior, and message serialization. Consumer-driven contract tests protect partner compatibility, while a smaller number of end-to-end tests cover booking workflows. I would inject timeouts and duplicate messages to test resilience. Synthetic or de-identified data is mandatory. Production monitoring and replayable fixtures can expose cases that ordinary happy path tests miss. Include unit, integration, contract, end-to-end, property-based, security, resilience, data quality, and ID impotency testing, along with realistic test data that contains no production PHI. Question 15. How would you migrate a monolithic healthcare application into microservices? I would not begin by rewriting the entire application. I would identify a bounded capability with clear ownership, expose an anti-corruption layer, and route one workflow through a new service using the strangler pattern. Data migration would be incremental, with reconciliation and rollback plans. Observability must precede cutover. After proving reliability, I would retire the old path and repeat. This reduces operational risk while gradually improving team autonomy and deployment speed. Talk about the strangler pattern, domain seams, incremental extraction, data ownership, anti-corruption layers, observability, rollback, dual reads or writes, and avoiding a risky big bang rewrite. Question 16. How would you design a resilient notification service for appointment reminders? The notification service would consume appointment events and schedule reminders according to patient preferences, consent, and time zone. A queue isolates booking from external email, SMS, or push providers. Each notification gets an ID impotency key, bounded retries, dead letter handling, and delivery status tracking. Templates must avoid unnecessary clinical details, and provider credentials stay in a secret manager. I would support provider failover carefully, because duplicate reminders can harm trust even when systems recover. Mention templates, patient preferences, consent, channel fallback, queues, scheduling, retry policies, provider limits, deduplication, delivery status, privacy, and avoiding sensitive content in messages. Question 17. How would you design caching for healthcare application data without exposing stale or unauthorized information? I would cache relatively stable, non-sensitive data such as facility hours or provider directory metadata, using short TTLs and explicit invalidation where needed. Patient-specific results require strict identity and authorization scoping, and some data should not be cached at all. Cache keys must include tenant and access context without embedding raw identifiers. I would prevent stampedes with request coalescing and monitor hit rate. Clinical correctness always takes priority over latency. Cover cache suitability, TTLs, invalidation, tenant and identity scoping, encryption, private versus shared caches, stale read risks, cache stampedes, and never caching data that policy prohibits. Question 18. How would you handle a downstream clinical system that becomes slow or unavailable? I would set aggressive, evidence-based timeouts and use circuit breakers so one failing dependency cannot exhaust application threads. Requests that can safely wait, such as non-urgent notifications, enter a durable queue. The user receives an honest pending status rather than fabricated success. Stale data may support limited informational views only when policy permits. It must never guide unsafe clinical decisions. Reconciliation jobs and alerts recover missed updates after the dependency returns. Discuss timeouts, circuit breakers, bulkheads, queues, fallback behavior, user messaging, stale data policy, reconciliation, retries with jitter, and distinguishing safe degradation from unsafe clinical decisions. Question 19. How would you manage patient identity matching across multiple facilities and systems? I would prefer a governed enterprise patient identifier, while maintaining crosswalks to facility-specific identifiers. Matching can use normalized demographics and deterministic rules, with probabilistic scoring only when confidence thresholds are validated. Low-confidence matches should enter human review rather than silently merge records. Every link needs provenance, auditability, and reversal capability. I would also monitor duplicate and false match rates, because an incorrect identity association creates serious clinical and privacy risks. Cover enterprise identifiers, deterministic and probabilistic matching, demographic normalization, confidence thresholds, duplicate prevention, human review, privacy, reconciliation, and never silently merging uncertain records. Question 20. How would you implement authorization for users with different healthcare roles and facility access? I would combine role-based permissions with attributes such as facility, department, employment status, patient relationship, and purpose of use. A centralized policy decision point can evaluate these attributes consistently, while services enforce the returned decision. Emergency access may require a break-glass workflow, justification, notification, and enhanced auditing. Permissions should be denied by default, short-lived where possible, and revoked promptly when roles change. Authorization tests must cover cross-facility and privilege escalation scenarios. Be sure to mention RBAC, ABAC, facility scope, purpose of use, least privilege, policy decision points, separation of duties, emergency access, auditability, and immediate revocation. Question 21. How would you design database ownership and data access across microservices? Each service should own the data it changes and expose behavior through APIs or events, rather than allowing other services to update its tables directly. For reporting, I would build governed read models or pipelines instead of joining operational databases arbitrarily. Local transactions remain simple, while events communicate changes. Schema migrations require compatibility and rollback plans. Shared infrastructure can be practical, but shared ownership and uncontrolled queries create a distributed monolith. Explain database per service principles, API or event-based access, read models, ownership, migrations, consistency, reporting needs, encryption, and why unrestricted shared tables create hidden coupling. Question 22. How would you secure and operate a containerized microservices deployment? I would build minimal, pinned images, scan dependencies and images, and run containers as non-root with read-only file systems when possible. Secrets belong in a managed vault, never in images or manifests. Network policies restrict service communication, while resource limits prevent noisy neighbors. C should enforce signed artifacts and admission policies. Deployments use health checks, progressive rollout, and rollback. Runtime monitoring then detects suspicious behavior and unexpected privilege use. Cover image scanning, minimal images, non-root execution, secrets management, network policies, resource limits, admission controls, deployment strategies, vulnerability patching, and runtime monitoring. Question 23. How would you approach a production incident involving incorrect appointment availability? I would first assess patient impact, declare the appropriate incident level, and assign an incident commander. Containment might disable affected booking paths or serve verified availability while preserving evidence. I would communicate clearly with support, operations, and clinical stakeholders, avoiding speculation. After recovery, reconciliation identifies incorrect appointments and affected patients. The post-incident review should examine code, data, deployment, and monitoring, then track corrective actions with owners and deadlines. Mention patient safety, incident command, containment, evidence preservation, metrics, rollback, reconciliation, stakeholder communication, root cause analysis, and corrective actions that prevent recurrence. Question 24. How would you improve performance for a healthcare API experiencing peak demand? I would establish a latency budget and inspect traces, database plans, queue age, and resource saturation before changing code. Common improvements include proper indexes, eliminating N+1 queries, right-sizing connection pools, caching safe reference data, and moving non-critical work asynchronously. Autoscaling helps only when dependencies can keep up, so I would load test realistic peaks and apply admission control. I would prioritize booking and clinical workflows over reports or background processing. Focus on measurement first, latency budgets, profiling, database indexes, query plans, connection pools, caching, asynchronous work, autoscaling, load testing, and protecting critical workflows under saturation. Question 25. Describe a trade-off you would make when building healthcare microservices at HCA Healthcare. I would choose a modular monolith before microservices when a domain is small, tightly coupled, or owned by one team. Microservices can improve independent scaling and deployment, but they add network failures, operational overhead, security boundaries, and debugging complexity. For a high-risk patient workflow, I would prioritize correctness, auditability, and controlled releases over maximum autonomy. I would revisit the decision using traffic, change frequency, failure data, and team ownership rather than architectural fashion. In your answer, discuss balancing delivery speed, reliability, compliance, maintainability, consistency, operational complexity, patient impact, and how you would validate the decision with measurable outcomes. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.